Hello and welcome back to the State Epidemiological Outcomes Workgroup Data Familiarization webinar series. Today is the second webinar of the 5-part webinar series. The next 3 webinars that you see listed here will take place live on Zoom, so we hope you will be able to join us for those. Today's topic is data considerations in the SEOW context. My name is Karen Bernhardt, and I am a research analyst with the Healthcare Workforce Group at the UND School of Medicine and Health Sciences. And I will be walking you through the webinar content for today. Here is a list of the topics we will be covering today. First, we will build off of the content from the first recorded webinar and discuss different types of statistics. We'll cover descriptive statistics, including measures of frequency, measures of central tendency, and measures of variability, along with going over what normal and skewed distributions are. We will also briefly discuss parameters versus statistics and also discuss inferential statistics. Then we will discuss the process of selecting data sources and go over some guidelines that can be used to select the best and most appropriate data sources for your needs. We'll also discuss making state versus national comparisons using multiple data sets and some considerations to take into account when doing so. Finally, we'll discuss a few geographical considerations with rural data. Descriptive statistics are used frequently with EpiProfile and other SEOWS data, so it's important to understand what they are and how they are used. These next slides are intended to tie the concept of basic descriptives to the broader concept of a data set. Descriptive statistics summarize or describe the characteristics of a data set. Common types of descriptive statistics that we oftentimes see and use are measures of frequency, measures of central tendency, and measures of variability. Using multiple descriptive statistics can assist in understanding the shape of your data. Shape can assist in determining if the data are normally distributed or if the data are skewed, which means the data lean in a particular direction. When we talk about data being distributed, what we mean by that is the mix of cases in relation to the whole. We will cover distributions in more detail in a little bit. As I mentioned on the previous slide, measures of frequency are one common type of descriptive statistics. Measures of frequency describe how often something occurs. This is generally seen with counts or raw numbers, as well as seen with percentages. These are used with discrete or categorical variables, which, as you learned in the first webinar, are variables with a limited or finite number of possible values, such as gender, for example. In SEOWS data, these types of statistics are seen with reporting stats, such as the number of men and women who ever tried cigarette smoking, or the percentages of students in each grade level who ever drank alcohol. Another common type of descriptive statistics that are often seen and used are measures of central tendency. These describe the center of a distribution of data. These measures include the mean, also known as the average, which is the sum of all of the values divided by the number of observations. It is important to note that the mean is very sensitive to extreme scores. The median is the middle number when the values are arranged in ascending or descending order. The median is less sensitive to extreme scores than the mean. The mode is the most commonly occurring value in the data. You don't tend to see this value reported too often. These measures of central tendency are used with continuous data, which, as you learned in the first webinar, are variables that theoretically have an infinite number of possible values, such as 1/100ths of a second of reaction time. In a normal distribution, the mean, median, and mode are all in the middle of the distribution. The final type of descriptive statistics that I'm going to cover are measures of variability. These measures describe the dispersion of the data. In other words, they describe how spread out the scores of the distribution are, or the degree to which the values vary from one another. These measures address the question, are values more spread out, or are they clustered together? There are a number of factors that can cause variability in a dataset. One of those is measurement error. People might measure things differently from participant to participant. For example, measuring head circumference may be done differently depending on who is taking the measurement. Another factor is individual differences. It is possible that the variable you are measuring simply varies from person to person. Things such as height, personality, and IQ all vary from person to person and can contribute to variability. Finally, treatment effects may also cause variability. Does the treatment really have an effect, or are the results due to random error or noise? These are just a few of the possible causes of variability in a dataset. This slide describes the different measures of variability. One measure of variability is the range. The range is simply the difference between the highest and lowest values in the dataset. This is not used or reported too often since it only takes into account the two most extreme scores. The standard deviation is another measure of variability. The standard deviation is the average distance of scores in a distribution from their mean. It answers the question, on average, how much do scores differ from the mean? A higher standard deviation means that your data points are more spread out from the mean. A lower standard deviation that is closer to 0 means your data points cluster around the mean. If all of your scores were the same, the standard deviation would equal 0, meaning there is no deviation from the mean. Variance is another measure of variability. Variance is simply the squared value of the standard deviation. We don't generally report variance or see it being reported too often because it is in squared units. So you will more commonly see the standard deviation reported since that is easier for people to interpret. Here you can see graphics of what a normal distribution looks like in comparison to skewed distributions. A normal distribution is when data are symmetrically distributed about the mean. Using the example of a bell curve, a normal dataset will have a majority of the cases somewhere near the middle or average of the dataset. Then, as cases get further away from the average, the frequency of cases drops. You can see that in the center graphic, the normal distribution has the mean, median, and mode all at the center peak of the distribution. A skewed distribution occurs when data are asymmetrically distributed. In the negatively skewed graphic, the mean pulls the tail to the left, while in the positively skewed graphic, the mean pulls the tail to the right. The first webinar covered populations and samples in a research and data context. As a reminder, population is defined as the entire set of units being investigated. And in the case of most data sets used by this work group, the population is usually people. A sample, on the other hand, is defined as the subset of the population available or gathered for investigation, which ultimately provides the data. Most of the data we deal with comes from samples and not entire populations. Now we're going to expand upon that information from the first webinar a little bit further by covering parameters and statistics. A population parameter is a value that would be obtained if the entire population was actually surveyed. In other words, parameters are values that describe populations. The key is that it includes everyone you are interested in. For example, a population parameter would be the average ACT score of all U.S. college students. On the other hand, a sample statistic is the obtained value from the sample. In other words, statistics are values that describe samples. An example of a sample statistic would be the average ACT score for 100 UMD students is 27. The key relationship here between parameters and statistics is that sample statistics are used to estimate population parameters. Now I'm going to briefly touch on inferential statistics. These involve techniques that allow you to make predictions and conclusions about a population based on a sample of data, as opposed to simply describing the data the way we do with descriptive statistics. In this case, it is assumed that the sample is representative of the larger population. Some of the statistical tests that are used in inferential statistics include t-tests, analysis of variance, or ANOVA, and regression. You may already be familiar with this information on various types of statistics, but it is important information to keep in mind when working with data sets. Now we're going to switch gears to selecting data sources. For our work with the SEOW, we need to find and select data sources on particular topics on a very regular basis. There are so many data sources currently available to us that it can be difficult to determine which ones are the most appropriate and the most accurate. I'm going to go over the general guidelines that we follow when creating the EPI profile and other SEOWS deliverables. We use the word guidelines here because it conveys some degree of flexibility, rather than using words like rules or laws, which tend to emphasize rigidity. The following bullet list contains general guidelines for data selection. They can overlap, but are ordered as most important to least important, with some caveats and exceptions, of course. The first guideline is that raw data is generally the best option if it is available, followed by summary tables, journal articles, and books in that order. This hierarchy is based on the time required to publish each one of these types of sources and make them available. It will take much longer to write a book, get it published, and get it out to the general public compared to putting a raw data file online for people to download. So if you are able to download the raw data file and work with that, it's usually the best course of action since it is likely the most recent information. If that is not an option, summary tables are a good next option. Many surveys, including sources like Burfus and YRBS, will publish summary tables that include frequencies for each of the survey questions. If neither of those two types of sources are available to you, you can utilize journal articles on the particular topic of interest. Finally, books can be a valuable source as well, as long as the publication date is being taken into account, since the data may be older in that case. The second guideline is that the data source should be topic specific if possible. Data sources tailored to specific topics of interest, such as alcohol or tobacco, are better than more general surveys that simply include a few questions on those topics. Topic-specific surveys, such as the Youth Tobacco Survey and the Adult Tobacco Survey, cover many facets of the topic of interest. So these are ideal if you are looking for tobacco-related data, for example. The third guideline is that newer data is generally better than older data. This one is pretty self-explanatory, but obviously more recently collected and published data will be more reflective of the current time compared to older data sets that were collected and published years ago. The fourth guideline for selecting data sources is that continuous data collection is better than sporadic or infrequent data collection. In other words, a survey that is conducted on an annual basis is preferable for establishing trends over time compared to a survey that is conducted every 2 years or every 5 years, for example. The fifth guideline is to look for surveys that include national and state level data, if this is something that you're interested in. National level data allows us to compare North Dakota to national numbers, as well as to border states or similar states, for example, states that have similar rurality. However, these types of comparisons should really only be done when they are made using the same core data or the same survey questions. I will go into more detail about why this is the case on the next couple of slides and describe the many factors that would need to be taken into consideration if you are attempting to make these comparisons using two different data sets or surveys. Finally, the last guideline is to look for overlap among surveys. Some surveys, such as BRFIS and the Adult Tobacco Survey and Youth Tobacco Survey, contain either the same questions or questions which are very similar to each other. This can be important to bolster the consistency of a finding when the results of each are similar. It is also important in the case when data is only available for one and not the other. Even if data for one of the surveys is not available at the time you need it, you would still have the other survey to obtain the relevant data that you are looking for. As I mentioned during the guidelines for selecting data sources, we often want to compare North Dakota statistics to US statistics to provide more context about how North Dakota is doing on particular metrics. This can be done easily and accurately when both the state data and national data come from the same source. We oftentimes make these types of comparisons in the Epi-profile. For example, the graphic shown on this slide comes from the most recent Epi-profile and shows the percentage of high school students who reported currently drinking alcohol for North Dakota and for the US over a number of years. In this case, both the state and national data come from the Youth Risk Behavior Survey. However, not all data sources include both state level and national level data. So you may be tempted to use two different surveys or two different data sets to compare state metrics to national metrics. This is a bit more difficult and requires more investigation into the two surveys that you would be using in order to ensure that the comparison made is as accurate as possible. If you want to make comparisons between state-level survey data and national-level survey data, ideally, as I mentioned, you should only make these types of comparisons using the same core data or the same survey questions. However, if that is not possible, and you would be wanting to use two different sources, there are a number of important considerations to take into account. Most of this information comes from Dr. Jill Herndon's presentation called Comparing and Linking Survey Data, Considerations for Working with Multiple Data Sources. The citation is listed here at the bottom of the slide if you are interested in viewing that presentation. I will go over these considerations to emphasize how cautious you should be when making these types of comparisons. First, you need to examine the primary purpose of each survey. The primary purpose for conducting a survey will determine the eligibility of the participants. For example, if the survey is focused on behaviors of college students, then those who are not in college would not be part of the survey sample. The purpose of the survey will also inform the specific questions that are asked and at what point in the survey they are asked. The questions will likely be formulated to address the specific goals of that survey. It is possible for two different surveys to ask questions about the same topic, but have different purposes and thus place questions in a different order or only cover certain aspects of the particular topic. Building off of the previous point, you also need to take into account the target population of each of the surveys. As I previously mentioned, this will determine who is included or excluded from participating in the survey. This will also impact how demographic information is collected. For example, if the target population is college students, the survey may not ask participants to report their annual salary, whereas a survey of adults may include that question. Additionally, depending on the purpose of the survey and target population, the response options for demographic questions may differ. One survey may ask participants to report their age and include 10-year age brackets as the response options. For example, 20 to 29 years old, 30 to 39 years old, 40 to 49 years old, and so on and so forth. On the other hand, another survey may ask the same question, but only include response options of under 18 years old, 18 to 64 years old, and 65 years and older. These are important things to note if you are wanting to compare the results of the two surveys, as the age brackets of the response options may not match up and could make it quite difficult to make any sort of direct comparisons. Another factor that should be considered when using two different surveys to make state and national comparisons is the methodology of those surveys. The way in which each survey was conducted would impact the response rates in the survey. Depending on the methodology used for data collection, some groups of participants may have been more accessible or easier to reach than others. For instance, if the survey was conducted by phone, only participants who have an active phone number would be able to potentially be reached to complete the survey. If the survey was conducted by mail, participants would need to have a valid address in order to receive the survey. If the survey was conducted using an online platform, participants would need to have internet access, whether that is at home or somewhere else, and potentially have an email address as well. Depending on the target population, one method of data collection may result in a higher response rate than another. It is also important to take into account the question wording and question placement of the two surveys. Even if the surveys are covering the same topic, such as alcohol use, for example, they may ask questions differently and use different wording in those questions. This could lead participants to have different interpretations of the questions and then in turn provide different responses to those questions. You would want to ensure that the questions are getting at the same core information and are asked in a very similar, if not identical, way. Question placement within the survey is important as well because it can impact the amount of missing data in the dataset. Questions that occur later in a survey are more likely to go unanswered. This is because some participants will not fully complete the survey and may quit part of the way through, or they may start leaving questions blank more towards the end of the survey. Finally, it's important to consider the time frame of the two surveys you want to compare. Is the survey conducted on an annual basis, or was it a one-time survey? These factors would impact your ability to do longitudinal comparisons and examine any trends over time. The time frame asked about within the questions is important as well. For example, if the survey is examining alcohol use, is it measuring alcohol use in the past week, the past month, or the past year? This is something to be aware of as well. The shorter the time frame covered by the questions, for example, alcohol use in the past week versus alcohol use over the past year, would likely lead to more accuracy of responses. It would be more difficult for someone to accurately remember and quantify their alcohol use over the past year compared to just in the past week. Hopefully, this information has helped to provide insight into the difficulties of making state and national data comparisons using two different data sets and help to inform the factors that need to be considered if you are planning to do so. Now we're going to talk about some data sources that can be used for state and national comparisons. First, we'll cover general population metrics. We can utilize these types of data to determine if a state, regional, or local comparison yields similar or different trends. This information can be used to establish background or justification for further investigating an issue, as well as show significance of a problem. Ideally, general population metrics can be used to compare your sample of interest to the general public. The U.S. Census Bureau is a wealth of information. The Census Bureau provides comprehensive population data, as well as data on key trends, such as disability status, for example. Aside from the main purpose of the Census Bureau, there are additional programs within the census product lines that can provide more information than just population counts. The American Community Survey, or ACS, is conducted on an ongoing basis. This is particularly useful for rural areas as the data gathered are aggregated over 5 years, which provides more reliable data over time. This is not the only product of the Census Bureau, as they also provide data on housing, insurance status, poverty, and even more beyond that. One common question that we are frequently asked as a team is why we have chosen a particular data set over another, when they both have seemingly similar data but may have different values. A good example of this is the Census Bureau data. If one were to look for the current population in North Dakota, you would find two values. For example, the population estimate for 2018 was either 760,077 people or 745,475 people, depending on the data table that was accessed. Why is there a difference? The two values come from two different sources, with the higher number coming from a data series that focuses only on population estimates. That is the sole purpose of that data set. The second and slightly lower number is an estimate from the American Community Survey. That estimate is used in conjunction with a number of other pieces of data that were collected. So, which do you choose? If you are solely interested in population estimates to use with non-census data, then you would likely choose the population estimates data. If you want to use an estimated population and another piece of ACS data, then you would use the lower number, as it corresponds to data collected the same way. It is possible to run into a scenario where you must choose one data source over another. The key to choosing which to use is which is the best fit for your needs, with the understanding that there is the potential that neither data set is perfect for your needs, but one is simply closer to what you need. Some other data sources that can be utilized for state and national comparisons are listed here on this slide. There are more options out there, but these are just a few common ones that we tend to use for SEOW's products. The first is the Behavioral Risk Factor Surveillance System. This provides data from all 50 states regarding health-related risk behaviors, chronic health conditions, and use of preventative services. This survey is conducted on an annual basis. The National Survey on Drug Use and Health is a good source as well. This provides estimates of substance use and mental illness at both state and national levels. This survey is also conducted on an annual basis. Finally, the Youth Risk Behavior Survey provides data on behaviors that contribute to the leading causes of death, disability, and social problems among students. North Dakota began participating in the YRBS in 1995, and this survey is conducted every 2 years. As I mentioned, there are certainly more data sources that can be used aside from the ones listed here and discussed in this presentation, but these are just a few options. The last topic we are going to cover in this webinar are some challenges and limitations related to data that are unfortunately common for rural areas. Being that North Dakota is a very rural state, it is important to be aware of these factors in regard to data for rural areas. First, there are some challenges faced when collecting data from those areas. Individuals living in rural areas may have limited internet or mobile connectivity. This would make it difficult to access or complete an online or phone survey. On the other hand, if data are being collected in person, there may be long travel distances, which could be made even more difficult during the winter months. These factors can lead to lower response rates in rural communities. To counter this, it may be advantageous to use multiple modes of data collection for populations in more rural areas. Rural areas with low populations and/or low response rates have the potential for data to be suppressed because not enough information can be collected. Data may be suppressed for reliability reasons. When the number of cases in a dataset used to compute rates are small, the resulting rates generally have poor reliability. This could lead to misinterpretation of rates or counts of data, so data may be suppressed in that case. Data may also be suppressed for confidentiality reasons. If there are a small amount of data points from participants from a particular rural county, there is a risk of being able to identify who these individuals are. In that case, data may be suppressed to protect participants' privacy and to prevent their identities from potentially being revealed. A secondary limitation is when smaller geographies are grouped together to obtain a large enough sample size. This can result in larger geographies that may not be comparable. That is all the content we have for today's webinar. We hope you found this presentation to be helpful and informative. The next webinar in this series will cover SEOW's EPI-profile data, specifically the alcohol and tobacco sections. This webinar will take place live on Zoom, so we hope you will be able to join us for that. If you have any questions or comments on the content in this presentation, please feel free to contact me at karen.bernhardt@und.edu. Thank you very much for your time.